In this video, I will go through a test that I just gave to my high school geometry class covering our probability unit. So this will serve as a nice review of basic probability principles. Alright, which of the following describes a pair of events A and B that are independent? Circle all the pairs that are independent. So independent means that knowing event A does not change the probability of event B. So let's say event A is it's a weekday and event B is we have school. Now, we have school 5 days a week. So if I just asked you what's the probability that we have school, if I just said what is the probability of event B, you would say that is 5 out of 7, right? 5 school days out of a total of 7. But if I told you, hey, event A, we already know that event A is true. We know that it's a weekday. Now what's the probability of event B? Now what's the probability that we have school? Well, if we know it's a weekday, then that means that the probability of event B is now 5 out of 5. Right? We know it's a weekday, so there is a 100% probability that we have school. I mean, I guess unless it's a snow day or something, but it is clear that knowing it's a weekday changes the probability that we have school. So that's why these two events are dependent. All right, they're not independent because knowing event A changes the probability of event B. So they are. So we are just supposed to circle the ones that are independent. So we're definitely not going to circle this one. So we're picking a random man. Event A is that he is older than 40. If we know event A, that is going to change the probability of event B, because event B is he is bald. And being older than 40 makes it more likely that he will be bald. All right, older men are more likely to be bald than younger men. So we are not going to pick this one because knowing event A changes the probability of event B. All right, and it works the other way too. I keep saying event A and then event B, but I could say knowing event B changes the probability of event A. It works either way. Now, these next events are going to be independent. I see that we're talking about rolling a die. And rolling a die is not going to affect if you roll a die twice, the first roll will have no effect on the second roll at all. So it really doesn't matter what these words are saying. Rolling an even number first, rolling a 5 second. It doesn't matter if you roll an even number or not. The probability of rolling a 5 is going to be the same no matter what. So this is independent. And same here, all right? We're still talking about rolling a die. So no matter how you roll the first one, your second roll is going to have the same probability, regardless of what happens with the first roll. All right, problem number 2. Now we're talking about mutually exclusive. All right, this is different than independent and dependent. Mutually exclusive just means that you cannot be in both sets at the same time. Both events cannot happen at the same time. So an example I like to use in school is if one set represents the group of freshmen and another event would be being a senior. All right, so I'm using F for freshmen and S for seniors. So you cannot be both a freshman and a senior. There's no overlap. So these two events would be mutually exclusive. Okay? As opposed to if I said one set is being a freshman and the other set is being a boy. You know? Now there's overlap because some freshmen are boys. These are overlapping sets now. So that's what we're talking about. Okay, so one event is likes grapes, and another event is went to college. These are overlapping. You could have people that went to college and also like grapes. So I'm not going to circle that one, because we're supposed to circle the ones that are mutually exclusive only. All right? Okay. Event A likes grapes. Event B likes pears. There could be a person that likes grapes and also likes pears. So there's overlap here. So I'm not going to circle that one. Event A is on a die, so we're rolling a die. Die is a single for dice. So event A is rolling an even number. Event B is rolling a 5. It's impossible for both of these events to be true at the same time. If you roll a die once, it cannot be an even number and also a 5. So these events are mutually exclusive, so we will circle this one. We roll a die once. Event A is rolling an even number. Event B is rolling a number less than 4. These events are overlapping because of the number 2. You could roll an even number that is less than 4 if you were to roll a 2. So these are overlapping. Both could happen at the same time. Both could be true. So I will not circle this one. So this is the only set that's mutually exclusive. All right, problem number 3. Let P equal the event people who play piano, and G is people who play guitar. Which of these shows people who play piano but not guitar? All right, so we want people who play piano, okay, but they do not play guitar. This is what we want. All right, if we were doing a Venn diagram of this, okay, so let's say this is the people who play piano, and this circle represents the people who play guitar. We are looking for only the people that would be, hold on, let me get my highlighter pen chosen. All right, we are looking for only the people that are in this part of the Venn diagram, right? All right, we want people who play piano, but they do not play guitar. So both of those things have to be true at the same time. So this is the symbol for and, by the way. So another way of saying this is we're talking about people who play the piano and they at the same time they do not play guitar. So this is what we're looking for. Okay, so the answer is B. All right, so we have this Venn diagram. 100 adults were surveyed. The results are shown here. Event C is owns a car. Event H is owns a house. All right, car owners and homeowners. So we're going to use this diagram to answer these questions. Okay, so this means the probability of not C given H. All right, the probability of not C given H. So in other words, this little bar right here, we say the word given. And whenever you have a given problem like this, you should highlight the given and cross out everything else. So H is what is given. So we're going to highlight the given. We're going to highlight H. And we're going to cross out everything else. So we're going to cross out the 24. We're going to cross out the 11. All right. Now, whenever we do probability, at its heart, probability is target over total. But when you have a given problem, you're crossing things out. You're narrowing it down to the given. So you have a new total. So there won't be 100 anymore. There's going to be 65. All right, I'm just adding up these two numbers. So that's going to be 65. So the new total is 65. Now, the target is going to be this part right here, not C. So which of these numbers represent not C? Well, 53 is represents the remaining car drivers. So not C will be the 12. So this is the target. So we're going to have 12 out of 65. So that's going to be the final answer. You could reduce this if you wanted to, but I'm just going to leave it as 12 over 65 for now. Actually, would this reduce? Maybe not. Okay, moving on to number 5. All right, so we're about to find all of these probabilities. So let's find the probability of C. By the way, when you see the P, it stands for probability. Probability is target over total. So all of these should be fractions as opposed to just whole numbers. So the probability of C okay, maybe I'll use these little diagrams that they have here. C is this. So in this diagram, that's 24 and 53. Okay, so if you add that up, that is 77. So we're going to have 77 out of 100. All right, remember we already know that the total is 100. All right, now we have the probability of H. So when we say the probability of H, we're talking about everything in this circle. So that's going to be the 53 and the 12. So that's going to be the 65. Okay, so the probability of H will be 65 out of 100, which would be the same thing as 65%. All right, now this is the symbol for AND. Okay, and you know what? In addition to these formulas that I have, I probably should have done this right from the beginning, but I want you to know that this is the symbol for AND, and this is the symbol for OR. So when you have an AND problem, you are always looking for the overlap. When there's an OR problem, you're going to do all of both. Okay? Also, AND is always going to be less than just one of the sets, and OR is going to be more than just one of the sets. So keep this information in mind as we do these problems. So this is an AND problem. So as I mentioned, AND is the overlap between the two sets. Okay, you know what? I should add one more thing to this. So when you're doing an AND problem, okay, the Venn diagram. So Venn diagram wise, AND is overlap, so we're looking for this portion of the Venn diagram. When we say OR is all of both, we're talking about this portion of the Venn diagram. So you can see why AND is less and OR is more. Alright, so immediately if we're doing C and H, that tells us that we are talking about this portion of the Venn diagram right here, which is 53. Okay, so you know that's going to be 53 out of 100. Now C or H, this is all of both, so we know we're talking about this part of the Venn diagram. Okay, so that's going to be all three of these numbers, everything except for 11. In fact, it's probably easier to subtract 11, which is 100 minus 11 is 89. So if you add these up, I'm sure that's going to be 89. So that tells you that the probability is going to be 89 out of 100. Okay, based on this data, are C and H independent or dependent? Okay, so when it comes down to numbers, if you want to prove that two sets are independent, we're going to use this formula, the multiplication rule for independent events. So, if this rule is true, that means the events are independent. If this rule does not work, if this equation gives us a false statement, that means the events are not independent, they are dependent. So let's use this rule as a test. All right, probability of A and B equals the probability of A times the probability of B. Okay, so let's check it out. All right, so we're asking ourselves, does the probability of A and, I'm sorry, we're talking about C and H. Does the probability of C and H equal the probability of C times the probability of H? All right, this is the question that we're asking ourselves. But we have all of these numbers right here. Okay, so the probability of C and H is right here. It's 53 out of 100. I think it will be easier if we convert this to a decimal. 53 divided by 100 is the same thing as 0.53. We just move the decimal point twice to the left. So does this equal the probability of C times the probability of H? But the probability of C is going to be 0.77. Okay, and the probability of H is going to be 0.65. All right, now if the answer is yes, then we're going to say independent. If the answer is no, then we're going to say dependent. All right, so let's check it and see. So what is 0.77 times 0.65? Okay, so that is 0.5005. Okay, so that is close, but not quite. So these are going to be dependent. So I'm going to say no. Therefore, the events are ... dependent. All right, had these been equal, all right, if we had gotten 0.53, then I would have circled independent. All right, an advertising company tested 3 versions, A, B, and C, of a commercial for a product. They showed the versions to 3 separate groups. Then they asked participants if they were likely to buy the product. The results are shown in the table below. Okay, notice that we have a total of 100. So, how many participants said, yes, I'm likely to buy the product? All right, so the yes is this row right here. And we're helpfully told that that adds up to 55. So 55 people. This is not a probability, it's just how many. So I'm not writing a fraction down right now, I'm just saying 55 people. Okay, now find the probability of N or not C. So the fact that this is a probability automatically means that I'm going to be dealing with a fraction. So target over total. This is not a given problem. It doesn't say given. That means the total is going to be the grand total of all the numbers. So I already know that's 100. Okay, so now I just need to figure out what this is. N or not C. Now, remember, or is all of both sets. All of both. So, if I were going to highlight these 2 sets, it would look like this. Let's start with N. All right, N is this set. Okay, now I'm going to highlight not C. So, not C... Here, I'll use a different color. Not C would be A and B. So that would be these over here. Now here's the key. I don't care about the green. That would be an and question. Or is all of both. So I'm going to add up all 5 of these numbers. So I should be adding up all 5 of these numbers to get the target. So it's all of the numbers except for 26, so it might be a little bit quicker to do 100 minus 26, which is going to be 74. Okay, so either way, that's going to give me 74 out of 100. So next, they ask for the probability of N and not C. So again, here is N, just like before. So you see we're talking about the same 2 sets, N or not C and not C. So my coloring on this picture is going to look the same. So here comes not C again. All right, but because this is an and problem, all right, of course we know that this means and this means or. Because this is an and problem, and is just the overlapping part between these 2 sets. So all I care about is the green part. All right, that will be the target because that's the overlap between these 2 sets. So that's going to be 13 and 8, which is going to be 21. So that's why we're going to have 21 out of 100. All right, now this little bar right here is read given. So we want the probability of y given b. Okay, so first of all, the total is going to change. Probability is target over total. Notice on all of these other problems, well, the previous two problems, the total was 100, right, which is the grand total. The only time that's going to change is when we have a given problem. So you should be on guard and ready for this number to change to something smaller. And the reason why it changes is because the way you do a given problem is you highlight the given and you cross out everything else. So in this case, the given is B. All right, group B. So I'm going to highlight the given and I'm going to cross out everything else. So that means I'm going to forget about A and C. Highlight the given, cross out everything else. So because I'm crossing things out, that's why the total changes. So the new total is only B. All right. In fact, when we do target over total, these given problems make it easy for us because the target is going to come from this first number and the total is going to come from the second number. Let's do the total first. So these two numbers right here. All right, so that's 20. So that's my new total. Now the target is Y. All right, the yes people. So the target is this part. All right, of course I'm going to ignore what I crossed out. All right, that's why we cross it out, so we wouldn't be tempted to use those numbers. So the only remaining Y part is this number right here, and that's going to be the target. Okay, so that is going to be 12. All right, so that's why it will be 12 out of 20. Okay, a triple Venn diagram. Counselors looked at 150 students, so that's the total, don't forget it. Looked at their schedules. The data is shown here. G is students that are taking chemistry. G is taking geometry. C is taking chemistry, and B is taking band. So, if one of these 150 students is selected at random, we're going to answer the following questions. So, what is the probability of G? Okay, notice the P, probability, target over total, we're doing a fraction, not just a number. Okay, not the best coloring job there, but we're in a hurry. So G is just these numbers right here. So we have to add those up. Okay, so 51, 18, 13, and 4. All right, so that's 86. All right, so 86 people out of a total of 150. All right, that's a probability of G. Okay, all right, interesting. So we have the probability of G or C or B. So remember, when we're doing an OR problem, it's all of both, but in this case it will be all of all three. So shading this little model down here, okay, it's going to be all of all three of these like this. All right, forgive my coloring job. So that's what we're doing. So comparing that to this, if I were to shade this, it would be all of all three. It would be everything except for the 12. Okay, so in your mind you should be thinking 150 minus 12 would be the easiest thing to do. That's going to be 138 people. Alright, so that's why we'll say 138 out of 150. Okay, now this is the probability of C given B. We love these problems. We'll just follow our procedure. You highlight the given part and cross out everything else. So we're going to highlight the B part, and we're going to cross out everything else. Okay, so we're just going to cross out this and this and this and this. We cross out everything else. Alright, so this is going to change the total. So the total will not be 150 when we do our target over total. The total will just be the B part. Okay, so you know what, I think I'm gonna, let me go ahead and actually cross out these numbers on this diagram. So we decided we were going to highlight the B part, right, which is all of this, and we're going to cross out everything else. So that's why we're going to cross out the 51 and the 13 and the 19 and the 12. So this is the new total. Okay, so this is going to be, so let's see, that would be 30, 45, 50. Okay, so this total here is 50. So that'll be my new total. Instead of 150, it'll just be 50. Okay, now the target is going to be the C part. Alright, so the target is going to be this part right here. That is going to be, no, I lied. Why does it zoom in when I do that? The target is the C part, but it's not just this over here. All of this little football shape, okay, that is the remaining C part of this picture. So it's going to actually be two numbers. Okay, so we're talking about this right here. That's the target, and that's 10. Alright, so that's why it's going to be 10 out of 50. So next they want to know, are events G and C mutually exclusive, or are they overlapping? So G and C are clearly overlapping because here is circle G and here is circle C, and they overlap right here. So we're going to have to justify our answer. So it would be helpful to use these numbers. So notice that there are 17 students who take both geometry and chemistry. So that proves that they are overlapping. So let's just make a sentence about it. So these events are overlapping because there are some students, 17, who take both geometry and chemistry. Okay, look at these 8 shapes. You randomly choose one of these shapes. What's the probability that you'll get a square or a white shape? Remember that when we talk about or, we're talking about all of both. So let's see. Which of these are squares? Well, we've got square, square, square. Now, which of these are white shapes? Alright, well, we've got white shape, white shape, white shape. All right. I checked this one twice. That doesn't matter because we want all of both sets. So I've checked all of the shapes that are either square or white. And so the probability, target over total, we already know that the total is 8. So it's going to be something over 8. And how many shapes are square or white? There are 5 of them. So the probability will be 5 over 8. Okay, so again, OR is all of both. So you just take all of the shapes that fall into either category, and there are 5 of those. Now, if I wanted to use one of my formulas, I could do that here. I could use this OR formula, this addition rule. So the probability of A or B is the probability of A plus the probability of B minus the overlap. Okay, so, and you know what, I can simplify this down a little bit. Sometimes I like to do the probability part at the end. So I could rewrite this formula like this. I'm just going to leave out the P part. So I could say A or B is equal to A plus B minus the overlap. Okay, I could just say that without the probability business. Okay, so how about if I think of it that way? So I want the probability of square or white. So I could say square or white is equal to square plus white minus the overlap. Okay, so let's see. How many squares are there? So square or white is going to equal the number of squares, which is 3, plus the number of white shapes, which is also 3, minus the overlap. Okay, the overlap would be a square that is white, or a white square. So there's one of those, so minus 1. So square or white is going to equal 6 minus 1, which is 5. And then, so that's the target, and I can just put that over a total of 8. Alright, so that's 2 ways to think about it. Problem number 16. You choose 2 shapes, one after the other, with replacement. That means we're starting fresh when we choose the second shape. Find the probability that you'll get a square the first time and then a circle the second time. So here's the main thing. Whenever you're choosing 2 shapes or 2 cards or 2 marbles or whatever it is, if you're doing 2 things in a row, you are going to multiply. You're going to multiply the probabilities. So if I want a probability of getting a square first, that means I need to find the probability of getting a square. And then I'm going to multiply that times the probability of getting a circle. All right, so probability of circle the second time. So what's the probability of getting a square? Well, target over total, there are 3 squares. There's a total of 8 shapes. So that's going to be 3 out of 8. Now, what's the probability of picking a circle? So there are 5 circles. So that's going to be 5 out of 8. Multiply those together and you're going to get 15 out of 64. So that will be the probability of both things happening in a row. Okay. We have to be a little bit careful when they say without replacement. That means we're not going to be starting fresh. So we will have to be careful about the second one. The second probability will change. All right, second probability changes. So just be careful about that. We're still going to multiply. As soon as you see that we're choosing two shapes, all right, in a row, we're still going to multiply. Okay, so find the probability that you will get a square the first time and a circle the second time. So we're going to find the probability of getting a square the first time, and we're going to multiply that by the probability of getting a circle the second time. Now, technically, I shouldn't just say the probability of getting a circle. I should say the probability of getting a circle given that we already chose a square. All right, so given that we already chose a square. But don't worry about that right now. Just use your common sense. So first we'll do the probability of getting a square. We already talked about that. We know it's going to be 3 out of 8. Squares go first, so we're starting with a fresh set of shapes. Okay, and the 3 out of 8 was because there were 3 squares out of a total of 8. Okay, now here's the thing. We picked a square, and without replacement means we don't put it back. So that means one of these squares is now gone. So let's say it's this one. So this square is out of here. So that means that there are no longer 8 shapes. Now there are only 7 shapes. So as we go to pick the circle next, we have to take that into account. So when we do the probability of grabbing a circle, we're going to do target over total. There are still 5 circles, so I'm still going to put 5, but there are not a total of 8 shapes anymore. There are only 7 left because we did not put it back. We did not put the square back. So that's why the new probability is going to be 15 out of 56. Okay, now we choose 2 shapes, one after the other, without replacement. So same deal as before. We're still going to multiply. Okay, and the second probability is going to change. Because we're not putting back whatever we take out first. So what's the probability that you'll get a square both times? Okay, so we need to find the probability of pulling a square the first time, and then we're going to have to multiply that by the probability of getting a square the second time. Okay, so I'm going to say the probability of pulling a square given that we already pulled out a square the first time. Okay, but don't get confused by this notation right here. It just means that the second probability is going to be different because we're not putting things back the way they were. So this is the third time we've discussed the probability of a square the first time, so we should be comfortable that that's going to be 3 out of 8. All right, because we're starting, the squares are going first, so that means we have a fresh set. All right, 3 squares out of total of 8. All right, so now we've picked a square, but we're not putting it back. Okay, so we're not putting that square back. So that's going to change the total number of shapes will now be 7. But be careful, because that also changes the total number of squares. We don't have 3 squares anymore because this first one is gone. So when we go to calculate the probability of choosing a square, for the second time, the probability, the total is going to be 7 now, because there are only 7 shapes left. But there are only 2 squares. So the probability of pulling a square the second time is going to be 2 out of a total of 7. Alright, so that is going to be 6 out of 56. Alright, 65% of students do chores. The probability that a student gets an allowance, given that he or she does chores, is 80%. Find the probability that a student gets an allowance and does chores. Okay, so for a word problem like this, this is really where we are going to need one of these formulas. We don't have a Venn diagram or anything, so this is where the formula is going to have to come in. But we need to decide which of these formulas we're going to use. So here's a hint. Notice that this first formula is the only one that has given in it. So if you see given being mentioned, this is the formula that we're going to use. Now this last formula is the only formula that says or in it. So if you see or mentioned, we're going to use this formula. Now this middle formula is the multiplication rule for independent events. So if they go out of their way to tell us that we have independent events, then we're going to probably wind up using this formula. But start by looking for given or the word or. Okay, so scanning through this, oh, they even highlighted it for us. Given that he or she does chores. So that tells me that we're going to end up using this first formula right here. So let's make a little list for ourselves. Let's start by picking the events. So some students do chores, some students get allowance. Those are the 2 events we're talking about. So we will let C be does chores, and we will let A be gets allowance. Alright, 65% of students do chores. So we know that the probability of C is 65%, or 0.65 is probably the easiest way to do these word problems, is with decimals instead of percents. The probability that a student gets allowance, given that he or she does chores, is 80%. So they're saying the probability of allowance given chores is 80%, which is 0.80. Find the probability that a student gets an allowance and does chores. So we're supposed to find the probability that a student gets an allowance and does chores. So since this is the thing we're looking for, I think I'm just going to call this X just to make it easier, just so I don't have to write probability of A and C over and over again. It'll just be simpler to look for the X. So now I'm going to set up the this formula. So the probability of A and B, the probability of A given B. So I'm going to rewrite this, but instead of A and B, I'm going to write A and C. Okay, so the probability of A given C is the probability of A and C, okay, divided by the probability of C. All right, I basically just replaced the B with C. All right, so this is the formula. Now I'm going to substitute in the values that we have. So we have the probability of C, so that means we know that the denominator here is 0.65. We have the probability of A given C is 0.80, so that's going to go here, 0.80. And we're looking for the probability of A and C, so I'm just going to put an X up there. So I just need to solve for X, and the way I solve for X is by multiplying both sides by 0.65. Alright, because that way these will cancel each other out. So this is going to give me the answer. So I'll do 0.65 times 0.80. That's 0.52. Okay, so that tells me that X is 0.52. So I could either put 0.52 or I could go back to percentages and say 52%. All right, but I would accept either. Number 20. At Roswell High School, 58 teachers have a master's degree, 16 teachers teach math, and 6 teachers have a master's degree and teach math. How many Roswell High School teachers have a master's degree or teach math? So there are actually a couple different ways you could solve this problem. One way is to use a Venn diagram. So I'm going to show you that way first. We could also use a formula, but I think using a Venn diagram is actually the simplest way. So let's see what we have. 58 teachers have a master's degree. So let's call this having a master's degree will be this circle, and then we have teaching math will be this circle. So 58 teachers have a master's degree, so I'm going to have 58 people in this circle. 16 teachers teach math, so I'm going to have 16 in this category. Notice I'm not writing those numbers down yet though, because of what comes next. 6 teachers have a master's degree and teach math. We've learned that we really have to start with that part of the Venn diagram. All right, 6 teachers have a master's degree and teach math. So that goes here in the Venn diagram. Okay, so now backtracking. So when they say 58 teachers have a master's degree, I'm not going to put 58 here because now I really have 58 and 6. That's too many. So instead, what I need to do is I need to subtract 6 from the 58. And that's the number that goes in this part of the Venn diagram. So I have to do 58 minus 6, and that tells me that there will be 52 teachers in this part of the Venn diagram, for a total of 58. Since there are 16 teachers who teach math, but we already have 6 of those recorded in the overlapping section, that means there are 10 remaining teachers in this part of the Venn diagram. So this really will give us an easy answer to the question of how many teachers have a master's degree or teach math. Remember what we learned about the word or. Or means all of both, and looking at a Venn diagram, it looks like this. So when we say math teachers or master's degree, we're talking about all of both. We're talking about all of this. Okay, so basically all we have to do is add these three numbers, and that will tell us how many teachers have a master's degree or teach math. Okay, and if you add up these numbers, let's see, so that's going to be 52, 62, 68. So that's going to be 68 people. All right, so 68 is the answer. So this is the easiest way of doing it. All right, so here we did 16 minus 6. All right, now if you didn't think of the Venn diagram and maybe you were trying to use the OR formula, okay, because I've probably trained you that when you see a word problem, you're probably going to wind up using one of these formulas. And we learned that if you see the word OR, then you're going to use the OR formula. The only thing that might have confused you if you tried to use the formula is this formula is set up for probabilities. See all these P's? But in the problem, probabilities are not mentioned. It doesn't tell you the total number of teachers at Roswell High School. So there's no way to calculate the actual probabilities. So what you needed to do, if you were going to use the formula, is realize that we've also learned that the same formula works for without probabilities. So if you're talking about A or B, you don't have to say the probability of A or B. You could just say A or B will equal A plus B minus the overlap. So we could use this version of the formula without the probability in it. So if you look at it that way, so instead of saying A and B, I'm going to use M and T. So if I want to figure out what's the probability of having a master's degree or teaching math, and I know that looks like it spells mutt, but it's master's degree or teaches math, then I could just do M plus T minus the overlap. Okay, so the number of teachers who teach, who have a master's degree or teach math will equal 58 plus 16 minus the overlap, which of course will be the 6 teachers who have a master's degree and teach math. So that's minus the overlap. And if you do 58 plus 16 minus 6, you will get 68. So that's the other way to do the problem.